Morning, everyone. Good morning. Shall we begin the session? Yes, today's topic is process control. In the last class, that is in the Friday's class, we have finished with the various topics of this EID, execution control, fork control, process, what is the process, how it is done. So now Unix provides a number of the system calls for manipulating the processes from the C program, and this section describes the important functions and examples of how they are used. So first one is obtaining the process ID. So each process has a unique ID that is known as the PID, process ID, and the get ID or get PID function returns the PID of the calling process, and this returns the PID of its parents, that is the process that created the calling process. This is hash includes sys types.h, hash includes uni_st.h, PIDT get PID void. This is one of the functions that is available over here to get the PID. Then PIDT get PPID void, and then get PID PPID returns or routine returns an integer value of the type PIDT, which on Linux system is defined in types.h as an integer. Then creating and terminating the process, how to create and terminate the processes. So from a programmer perspective, we think of a process as being of the following states. This is running. The process is either executing on the CPU or is waiting to be executed and will eventually be scheduled by the kernel. Scheduled in the sense how it is scheduled by the kernel, how it is take place with the kernel, with the CPU, how it is waiting for this one. Then next one is stopped. So the execution of the process is suspended and will not be scheduled. So that means it is stopped, it is stopped, it is stopped. Then signature terminal also used, signal also used, that remains stopped until it receives a count signal at which it points to, at which it begins running again. So running is done, stopped is done, terminated, that is a stop permanently. So a process becomes terminated for one of the three reasons. That may be any of the reasons that is available for terminating, that means removing the process. So one is receiving a signal whose default action is to terminate the process, returning from the main routine, then calling the exit functions. These are the three categories, these are the three, we can say, the ways by which a process terminated for any of the three reasons. From any of the three reasons. One is receiving a signal whose default action is to terminate the process. That means a default action is given that is used to terminate the process, returning from the main routine, calling the exit function. This is hash include std library.h void exit int status. This function does not return anything, and the exit function terminates the process with an exit status of the status, and the other way to exit status is to return an integer value from the main routine. So this parent process creates a new running child process by calling the fork function, that is hash include systypes.h hash include uni_st.h. Then PID t fork void then returns 0 to the child, PID of the child to the parent, -1 on the error, and the newly created child process is almost but not quite identical to the parent, and the child gets an identical but separate copy of the parent's user level virtual address space that includes a text, that includes the data and the BSS segment. Then heap and the user stack, and the child also get identical copies of any of the parent's open file descriptor, which means the child can read and write any files that were open in the parent when it is called fork. And the most significant difference between the parent and the newly created child is that they have a different PIDs. And that is also very interesting because it is called once, but it returns twice. Once in the calling process, once in the newly created process, and that returns the fork process also, PID of the process also, that is of the value 0, that is for the PID that remains a non-zero element that provides an unambiguous way to tell whether the program is executing in the parent or the child. Then this shows an example of parent process that uses the fork to create a child process. And when the fork call returns in line 8, x has a value of the 1 in both the parent and the child. This child increments or decrements or prints its copy of the x in the line 10. Similarly, the parents also decrements and prints its copy of the x in line 15. And when we run the program on our Unix system, we get the following result. This is Unix fork parent x0 child x equals to 0. And there are some subtle aspects to this example. This is call once, return twice, concurrent execution. That means it is once called, and yes, it is calling once and it is returns the twice value. And the fork function is also called. Once by the parent, but it also returns twice, once to the parent, once to the newly created child. And this is fairly straightforward for the programs, for the keys, what should do for the keys that is taken out as a confusing key, as a confusing part, and needs to be aborted or needs to be reasoned very carefully. That is what is the main reason to be followed up, that is called once and returns twice. The next is concurrent execution. So the parent and the child are the separate processes that run concurrently, and the instructions in their logical control flows can be interleaved by the kernel in an arbitrary way. And when we run the program on our system, so the parent process completes its printf statement first, followed by the child, and it can also run the system with the reverse, that might be true, that might be used with a general category, with a general, that as a user programmer we can never make the assumptions about the interleaving of the instructions in the different processes. This is one of the code. First of all, there is a hash include cs app.h, then int main, that is a main function. Now we are taking the variable as a PID of the PID t type. Then int x equals to 1, then PID equals to fork, that is a fork function. And if PID equals to 0, that means if PID is 0, then printf child plus plus x. Then exit, yes, exit 0, then parent, printf parent minus minus x, x is 0. Then duplicate but separate address spaces. So if we could quote both the parent and the child immediately after the fork function returned in each process. So whatever the parent do, whatever the child do immediately after the fork, that will return in each of the process. That will use the same code as we use a local variable value, same heap and the same global variable that could take place in the same code. Therefore, in our example program, local variable x has a value 1 in both the parent and the child when the fork returns in the line 8. So this will be used as a parent process, child process, that are separate processes. They have a private address space also. So this is call once, read many times, or return twice. Concurrent means at the same time, then shared file. So when we run the example program, we notice that the both parent and the child print their output on the screen. And the reason is that the child inherit all of its parents or open file, and whatever the parent do, whatever the parent call folks, then std out file is also opened and directed to the screen. So the child inherits its files and therefore its output is also directed to the screen. So whenever we are using, so when you are learning, first learning about the fork functions, it is very helpful to sketch the program or process graph, where each horizontal arrow corresponds to a process that executes an instruction from left to right, and vertical arrow corresponds to the execution of a fork function. This is call fork once, this is print to output files. So this is hash include cs app.h, int main, fork, printf hello, exit 0. So this printf function is used with the hello, with the exit 0, then int main, so then prints the two output files. So this is hash include cs app.h, int main, fork, printf hello, exit. Then calls fork twice, hash include cs app.h, prints the for line, then fork, print hello, exit 0. Then call forks 3 times. This is print 8 output line. This is hash include cs.app.h, int main, fork, printf hello n, exit 0. Then example of the fork program and their process programs, or the graph that is used in the fork function, that is used in the program. This is used to fork the 3 times. Yes, it is used to fork the 3 times. Then how to repeat the child the reaping, not the repeating, it is reaping the child processes. So when a process terminates for any reason, the kernel does not remove it from the system immediately, but it reaves down the system immediately. So instead, the process is kept in a terminated state until it is reaped by the parent, and when the parent reaps the terminated child, the kernel passes the child exit status to the parent. Then discard the terminated process, at which point it ceases to exit. And the terminated process that has not been reaped is known as a zombie. And if the parent process terminates without reaping its zombie children, the kernel arranges for the init process to reap them, then uses the PID of the one that is created by the kernel during the system initialization. And the long-running programs, such as the shells or the server, should always reap in their zombie children, and even though zombies are not running, they still consume system memory resources. And the process also waits for its children to terminate or stop by calling the wait PID function. This is hash includes sys types.h sys wait.h. This is PIDT, wait PID, PID, int status, int option. This is very complicated, and by default PID also suspends execution of the current process, calling process, until a child process in its wait stage or terminates. The next is how to determine the member of the wait state. So if PID is greater than 0, then the wait state is the singleton child process whose process ID is equals to PID. And if PID is equals to -1, then the wait set consists of the parent-child process that also supports other kinds of the wait sets involving the Unix process group that will not be discussed over here. Then modifying the default behavior. How to modifying the default behavior? That is wo hang when traced. That is that return 0 if none of the child process in the wait set has terminated yet. And the default behavior suspends the calling function process until a child terminates. And this option is very useful in those cases where you want to continue doing the usual work while waiting for the process to terminate. That is WNO hang, WUN traced, WNO hang, WUN traced. Then checking the exit status of the reap process. So this is WI or W if exit, W exit status, W if signal, W terminated signal, W if stop, W stop sig. This returns a number of the signal that causes a child to stop, and this status is only defined if with stop returns true. Then if the calling process has no children, then wait PID returns -0 and set error number to the EC child. And if the wait PID was terminated or interrupted by the signal, then it returns -1 and set the ERR number to EINTER. This bits in the third argument to wait PID, that is hash define WHO hang, don't block waiting, hash define WUN trace, then report status of the stopped children. In order to use these constraints, you must include the wait.h header file into your code. This is the wait. Why? Because this is waiting for this. Then int main, if fork equals to 0, then print A, else print B, then wait PID -1 null 0, printf C, exit 0. Then wait function, yes. So just wait, okay. Now let's see what is the main function or what is the wait function of this one. That is a simpler ID or simpler version of the wait ID. This is hash includes sys types.h, that hash includes sys wait.h. Then PID wait in status. So this PID of the child if OK or driven -1 on error. So this is one of the main program that lists all of the possible output sequence for the following program or sequence. This is int main, if fork equals to 0, then print A, else print B, wait PID is -1 null 0, then printf C, exit 0. This is the wait function, that is a simpler version of the wait PID. This is hash includes sys type.h, sys wait.h, then PID wait in status. Then calling the wait and status is equivalent to the calling wait PID minus 1 status 0. Then example of using the wait PID that becomes complicated, that is helpful to look on the few program that shows how to use a PID function. How to use a PID function that returns in the line 12 that each cycle exits with a unique exit status. And before moving on, make sure you understand why line 12 is executed by each of the children, but not the parent. Then in line 15, the parent waits for its children to terminate by using the wait PID as a test condition of a while loop. So this is using the while loop, this is using the test condition of the while loop. And because the first argument is minus 1, the call to the wait PID blocks until an arbitrary child has terminated. As each child terminates, a calls to wait PID returns with the non-zero PID of that child, and this also checks exit status of the child and if the program or if the child terminates normally, in this case by calling the exit function, then the parent extracts the exit status and print on the std out. This is hash includes csapp.h, hash includes n2. This is int main, int status id, PID, PID. So this parent creates n children that is used. So this I equals to 0. I equals to 0, I is less than n, I plus plus. So if PID equals to fork, function equals to 0, 0, then exit plus I. Then parent also reads n children in no particular order. And while PID equals to wait minus ID status 0, that is greater than 0, then y or the y or w if exit status, then child normally will executes or exit status, that is a W exit status, then else printf child terminated normally. And the only normal termination as if there are no more children. So if error number is not equals to each child, then Unix error wait PID errors. And this wait PID is also returns normally with the exit function with the exit status equals to 100. In the same way, exit status equals to 101 in the case of the child 22967. Notice that the program raised to children in no particular order, and the order in which they are raised is a property of this specific computer system. On the other hand, this is also used with a normal repetition in the normal system execution, or even another execution also takes place in this execution. This is one of the example of the non-deterministic behavior that can make the reasoning about the concurrency so difficult that is never assumed that no one or no outcome will always occur, or no matter how they are likely to use, how they are using with the possible outcome that is equally likely. And this figure also shows a simple change that eliminates this non-deterministic in the output order by reaping the children in the same order in which they are created by the parent. And in line 11, the parent stores the PID of its children in the order and then waits for the another PID in the same order by calling the PID with the appropriate PID in the first argument. That terminates with the process, that uses with the process with the PID that eliminates a non-deterministic process. This is one of the example. This is int main. Yes. Int main, int status. So we are declaring the variable as a status. Next variable is PID, that is of the PID t, then printf hello, then PID equals to fork, then printf fork or the PID. Now, if PID is not equals to 0, then wait PID minus 1 status that is greater than 0, then W if exit not equals to 0, printf W exit status, then printf bye bye, then exit 2. This is used as a status, this is used as a program that is used with the wait problem 0. How many output lines does the program generate? What is the one ordering of these output lines that is generated? Now next is putting the processes to sleep. So the sleep process also suspend the process or the process for a specific period of the time. This is hash include unist.h, then an unsigned int sleep int sec. Yes, sleep returns 0 if the requested amount of the time it has elapsed and the number of times it has elapsed the second to sleep the process. It is terminated by the signal also. This is unist.h, then int post void. Then how to load and execute the program. This is the function how to execute and load the programs. So this Unix function, that is argument list, this is represented by the data structure that is given over here. This is the argument v. This is the argument function or argv function that includes the various behavior. So there are multiple variables of this array. One is 0, one is 1. This is still argc minus 1 or the null values. Then this shows ls, lt, user include. This is int main, int argc, char argv, char envvp. Int main, argc, argv, envp. And when the main begins in a 32-bit line-S process, the user tracks with the organization. Let's have work one way from our bottom of the stack to the top, that is the lowest address. This is the getvnv function, such as the environment array for the string name equals to array. If found, it returns a pointer to value, otherwise it returns the null value. This is another program that shows the fork and the exev function to return the program. This is the function prototype. That is the exit function, eval function, cmd line, complete, foreground, that is used to pass the command line. Evaluation function calls a built-in command function, which checks whether the first command line argument is built in a shell command. If so, interrupts the command immediately and returns the 1. Otherwise, it returns a 0. This is the case when we are using the built-in command. This is the case when we are using the unnecessary or the useful commands. Now this is one of the function how to evaluate the command line argument that is available over here. This is the parent waits for the foreground job to terminate. This is used with the built-in command, then returns a 0 terminating array, or it is used the job work in this one. Last part is signal that we have already done. This is known as the Unix signals. Yes, profiling timer, virtual timer, these are the signals. So this is simply a short message or a small message that notifies a process that an event of some time has occurred. That means, for example, when we talk about that signal, there are two types of signal. One is asynchronous, one is asynchronous. This is occurred in the system with the signal type, with the signal property. So yes, the man7 signal on the shell command gives the listing of the processes. Then signal terminology, that is occurs in the two distinct steps. One is sending a signal, one is receiving a signal. We can send the signal, we can receive